Welcome back. Let's go over relational database implementation. This is a build your own database program, which is kind of cool if you think about it. You'll get bragging rights. You can boast to your friends and future employers that you wrote your own database. And so in particular, I'd like you to implement a select operation, a project operation, a join operation, and then a union operation. And then run these 4 queries down here. So I'm calling them queries. They're really just a series of operations. And these are done already. These are the same queries that are in the previous assignment from the textbook. So if you've done the previous homework, then you've already got the series of operations that you need for each one of these guys. So let's go through some of the resource files that are posted for you. I've got this C++ file posted. I've got some input text files in comma separated format. And then probably most importantly is the class notes. All right, so let's see. So I've got some resources that are posted on the website. There's this tables.zip, and if you get inside that, there's like the buyers table, for example. This is just comma separated values or CSV files. They're just text files. So you need those. Well, you could write them, you could do them yourself, but I've provided them for you. Then you've got this CPP file, which I've got opened up right here. So let's kind of go through this thing and talk about some of the code issues. So tables, I'm just using global tables. So these are 3-dimensional character arrays, or you could think of them as 2-dimensional string arrays. So the first value is the size of the string. So there's 100 characters in a string. There's 100 maximum rows in a table, and then 80 columns. So it's characters, or string length, then rows, then columns. So this is kind of a wasteful way to allocate memory in general, but it makes the coding a little bit easier. So I'm using global arrays, and you could create more of these if you want. And then the other thing that I'm doing is I'm passing these as arguments into a function. That seems odd that I would have global data up here, but then pass the global data as an argument. And the only reason I'm doing that is that, well, if you didn't do that, then these tables would be local variables. That is, they'd be declared on the stack, and that uses up a lot of stack space. And the other thing you could do is make these local and declare them as static, and that would be the same thing as in terms of where the memory is allocated. It would be allocated in the same place that global arrays are allocated, but the static modifier in the local, if you declared them down here in local, would make them visible only in the local function. So you could do it that way, but it doesn't really matter in terms of just getting this thing done. And so it's easiest to deal with these 3-dimensional arrays just declared in main. So anyway, so I've given you this function right here is a really important function because it sets up the looping structure that you could use for the rest of these functions. So here I'm looping through rows in a table, and the loop is terminated by finding the null terminator, because I'm looking at the 0th character in a string. So basically the first character in a string, and if that's a 0, the actual value is 0, not the ASCII character 0, but the value 0, then it terminates the loop because 0 has a value of false. So this is the looping structure that I'm using, and you could use the same similar looping structure. So study that until you understand what's going on in there. And in order for that to work, I'm writing zeros to the blank elements of the array, and that's what this erase table function does. This guy right here, it just writes zeros to every. Looks like I'm writing zeros to every single element in the array, which is more than you need to do. Really, I only need to mark the first element as with a 0, to indicate that that record is blank, but just to be neat, I'm just erasing everything. So it's a triple nested loop where I erase every element. But anyway, the zeros at the first element is what's used to terminate these loops up in here. Okay, so you can use this looping structure to implement these other functions I'm asking you to implement. Where are they? Here, like for example, I'm asking you to implement select. So this is just blank right now, and you need to fill this in with code. And so let's just kind of go through it a little bit. Select operation. This is the output, T out. So I'm passing a table in by reference, basically, and then you can modify T out in the code here somewhere, and then when you return back to the calling side in main, then T out will have the data that you need. And T in is the input table. You're just reading from that, and the column value is for the select operation. That's the column that we're looking for a particular value in, and then the value parameter is the value that we're seeking in that column. So you might call that in main down here like this. You might declare a temporary table. So I'm using static here so that I can declare this in main, which is a function. I'm using static just so that this memory that I'm allocating here is actually in the global code space instead of the stack. That's why I'm using static. So anyway, I'm making an array that's going to contain the output data, and I'm passing that by reference into select. And I'm using, for the input table, I'm using table 2, which I filled up with students here just for this skeleton program. And then I'm looking in column 1 for the values 555 Riley. And I think this thing does, all it does right now is it prints out the professor's table and the student's table. And the other functions don't work because I want you to implement those. All right. So yeah, I've given you some functions that fill tables up. In this case, I'm filling professors and students, but you need to fill up, buyers and suppliers and all the tables from the homework. Okay, then do a series of operations to perform a query. So it might be a select followed by a project followed by a join, or whatever you need to do these four queries right here. Like whatever it takes to do that, it's going to be a series of operations, either selects or projects or joins, whatever. Do those in main, and do that for all 4 of these queries here. Okay, so yeah, do that. Study what I've given you and implement these functions: the join function, the project function, the select function. Okay, now very importantly is what's in the notes, what's in the class notes. In particular, this stuff. There's the pseudocode for select, there's the pseudocode for project, here's the pseudocode for join, and here's the pseudocode for union. Okay, so you need this, you really do, especially when to do these iterators. Right, I'm trying to show with indentation, when the iterators get reset, right? So yeah, this will save you a lot of time. And I think that's about it. Here's union. What else is there to say? Is there any more? Let me scan this real quick. Is there anything? Here's a string copy that I'm using. Here's how to use string copy. You're going to need that to copy from one element of a table to another element of a table. Let's see. Now the other thing you need to have is you need to put those text files, the employees and whatnot, put it in the same file as or the same folder as your source code so that it can find it. And that's about it. Okay, so get these guys working and fill out main. Main's going to be pretty long. You know, here, this is just 4 operations, but you're going to need to do, a lot of operations. You need to create the initial tables and fill them up, create some temporary tables, call the operations, you know, generate some output that sort of documents the execution so that someone can see that it's really working, and do that for all 4 of these operations right here. Okay, so if you haven't watched the video before this, where I talk about the general theory of relational databases, and then I spend a lot of time going through these algorithms right here, you really need to watch that. Okay, hope this was helpful to you. See you next time. Bye-bye.